Hey, it's Radical Dan. This is a carbon electrode. Well, it's actually graphite. It come out of the center of a battery, and I've been using these on my carbon arc furnace. And I'm looking for graphite. So I'm going to the store looking, and everybody's like, "Oh, you can use pencil lead, but that's got clay in it." So what I did is I basically took a piece of one of those and I crunched it up into a powder, and you can see right here that it's conductive, because if I run my leads down into the powder itself, I'm actually getting, it conducts electricity. See if I do it. I do it just right across the cup, which is ceramic. See, it's not conductive. So the powder is actually conductive. Alright, I'll be back. Okay, here's a piece of plastic that's it's like plastic they use for laminating. I'm pretty sure it's polypropylene. But what I did is I smeared regular charcoal on this. So if I try to get a resistance or conductivity, there's no conductivity. Okay. So if I go the same with the sheet by itself, it's the same thing. But now if I take it to this here, which is the graphite, which I just spread on my fingers, so now it's going down. It's set on 20 mega ohms, so that's 1,000,000.4, and it's going down. So it's actually conductive. All that is graphite spread over this plastic. So what the idea is that if you can spread graphite, because the plastic has an electrostatic charge to it. Okay, so when you spread it over there, it's going to attract particles. Well, the whole idea of graphene is it's a single layer of carbon atoms. So if you take graphite, and basically, as you rub it into this plastic right here, because of the shear force of the particles, it will actually take off layers until you're left with like a single, or close to a single layer. So technically that should end up being like a transparent conductor, which is what I'm looking for. I'm looking to try to make a piece of plastic into a conductor that is transparent, that light can go through it, because then I can work on building a solar cell with a transparent conductor on the top, and then some kind of a, I don't know if you use like Einstein's photoelectric effect, where certain metals will give off electrons when they're hit by certain frequencies of light. And a good example of that is what is it, I don't want to say tin. What is it? It's not nickel. It's I don't know. What is it when they galvanize? Zinc. It's zinc. When they zinc plate something, it's galvanized. Zinc is actually one of those metals that when certain frequencies of sunlight hit it, now normally it's in a vacuum, because the old tests they did were in a vacuum, but normally when a certain frequency of light hits zinc, it ejects electrons. When the photons hit it, it excites the electrons, and of course it ejects one. So what the idea is to put a conductor on top of the metal and kind of make a sandwich type solar cell to see if I can do that. But anyway, that's what I'm checking right now. I'll be back. Hey, it's Radical Dan. There's another experiment I'm going to try with this graphite dust that I made. What I'm going to try to do is I got some acetone here, and what I'm going to try to do is make electrodes. I'm going to make some electrodes that are like graphite electrodes. I'm not sure if this will fit in there, but yeah, there we go. Just put the styrofoam in it. Just let it dissolve. What this will do, it kind of makes like a poor man's napalm or whatever, but what I'm doing with it is I'm adding the graphite powder into it, so that way I can make it into little shapes. These look like electrodes, and then when it dries out, it turns back into like a hard plastic. So you can watch it change it. It'll get dark. So it's starting to pick up the graphite. I'll put some more in there, I think. I think this is big enough. Maybe. It's too big for the cup. There we go. Yeah, this is what they used to call poor man's napalm. You take gasoline or acetone and you'd soak styrofoam in it. And then it gets all gooey and runny and stuff like that. And then what you do is, like, when you throw it at something and you get it all caught on fire, because it burns really good. But when you throw it, it sticks on stuff, and it's really hard to come off. So that's what these call poor man's napalm. I think this might be enough right here. I don't know. But I'll pull it out when it's done, and I'll let it dry, and I'll show you guys. And hopefully it'll be conductive, so then I can use it in like hydrogen cells or certain kind of cells that attack different metals, but they don't attack plastic. So we'll see. All right, I'll be back.